Talk about box plots today. Now they have another name. It's called box and whisker plots. I guess that one's a little bit older in name, but that's sometimes you'll see that written on standardized testing and different things like that. But we're going to talk about a box plot. Since it's got the term plot in it, it's still going to use the idea of a number line. Okay, but it's going to do something slightly different. It's going to measure. So I don't know why this is there. Apologize. It's going to go ahead and measure variation. So it is a graph that shows, let me fix my spelling, apologies, that shows distribution or variation, that shows variation. Okay, so it's going to look at those chief measures of variation, our median, our quartiles, our IQR, our upper and lower extremes, so our ranges, as well as outliers. And you really can't use it for mean absolute deviation, but that's about the only thing it doesn't show on variation here. So you can see that's what a typical box plot would look like, and this is what we'd have. So a couple of things to add to it. So because it's a box plot, we know the median is the middle. Another way to say that's 50% of your data. So this could be called the lower half, and this side would be called the upper half. Okay, that would make here, so that's 50% data. This is your 25. Your Q1 is actually 25% of your data, and your Q3 would be 75%. So each section, this would be 25 here, this would be 25, 25, and then all down here, all the way out to the outliers, another 25% of your data. So that shows this idea of kind of how these quartiles work and how that would break down. Let's go ahead and take a look and create our first box plot. To do that, our first thing we have to do is find our measures of variation. And the first one we have to really do is find our measures of our median. So the first thing we got to do is go ahead and put an order from 19, and then 20, and then 22. I got to do this carefully, otherwise I miss them. And that's one of the things we've got to learn. 23, two 25s. Then I see a 27. All right, that's all my 20s. Let's get those marked off. Then I've got a 30, a 34, a 35, and a 40. 30, a 34, a 35, and a 40. So I've got all my data here. So I've got it organized enough that I'm going to be able to find my median, my quartile 1, my Q2, my IQR, and we really won't need to find that one, but it's good to have, and our range. Okay, so we can find all that information. So I have 11 pieces of data. So that makes my center point going to be 25. So here's my median. So I've got 5 on either side. So my Q1 is 22. My Q3 is 34. Sorry, I made that a 2. Q3 is 34. My IQR would then be 12, and my range would be 21. Just to kind of think this through, would I have an outlier in this data? Well, 1.5 times 12 is 18. 22 minus 18 is 4, so I have nothing no lower than 4. And 34 plus 18 is 52. I have nothing greater than 40, so I have no outlier in this case. So the first thing I'm going to do is then I'm going to create my plot. I'm going to create my number line. So my number line, I get to create the scale. Since I have a range of about 21, I'm going to go with about 4 or 5. So let's say 4. So we'll start a little below our number, and I'm going to go with multiples of 4 just to make our life easier. So we're going to say this is 16, 20, 24, there we go, 28, 32, 36, 40, 44, and I can probably stop there. So I'm going to go ahead and just extend that, and I'm going to turn this into this, kind of shorten out my number line. So now that I've got this taken care of, I'm going to plot my data. First thing I'm going to do is going to plot my mean, or not my mean, my median. So 25 is right about here between 25 and 26, 24 and 26, and then my lower quartile is 22. That's going to be right here. My upper quartile is 34. That's right here. So I just put a line there, and now I'm going to connect them to create the box for our box plot. And then last thing we're going to do is we're going to take a look at and mark out my extremes. So my lower number, my great upper extreme, the top of my mean is 40. My lower extreme is 19. Puts it right about here. And that's my box plot. Okay. So again, we've got our median here, my Q1, my Q3. This is my upper range and my lower extreme and my upper extreme. All right, it's your turn to go ahead and put the data together and create a box plot for this information. Go ahead and pause the video, and when you're done, you can check your work. All right, so the first thing you did was put it in order, 350. Then you went ahead from 350, you went up to 460. That's a big difference. It might be something to keep in mind for an outlier in a minute. 475, oh sorry, 450, I missed one. 450, 460, 475, 480. So I've got all my fours, 4, 4, 4. Okay, now we go to 500. I've got a 500, 15, 20, 25, 40. 500, a 515, a 520, a 525, and a 540. So it's still good numbers, so let's go ahead and put all my commas back in. So this time I have 10 pieces of data, so my middle is going to be right between the 5th and 6th data point. So 1, 2, 3, 4, 5. So that means my mean's right here. So my median is going to be 490. My Q1 is going to be 460. My Q3 is going to be 520. That makes my IQR 60. And then my range is going to be 190. So I'm going to check. I'm going to say I probably do have an outlier in this one, and I'm going to have to create it differently because I have the outlier. So 1.5 times 60 is 90. 450 minus 9 is 360. So definitely I have an outlier here. And I know if I add 90 to this is 610. I don't have an outlier on the upper end. So I do have an outlier at 350. That's going to change the way I create my graph. But I think I am going to go ahead and start it at, I'm going to do 50 this time. So I'm going to put my lowest number at 300, 350, 400, 450, 500, 550. That's as far as I need to go. Sorry, 550, not 500. So that's my number line. I'm going to go ahead and create it together. It's not a very straight line, but please apologies for that. So now I'm going to go ahead and create my box plot. So if my median is 490, that's going to put it somewhere closer to right about here. My Q1 is 460, that puts it right about here. My Q3 is 520, that's right there. And that's not perfect. They may not be exactly in the right spot, but they're pretty darn close. My upper extreme is here. Now, because I have an outlier, I'm going to mark the outlier with a star and make 450 my lower extreme. So you can see that's going to look a little different because I did prove I have an outlier in this case. All right, now that we've looked at that, let's read what it says. Okay, so half the drivers are driving faster than what speed. So because we talked about this at the very beginning, the median right here is the middle. That's the 50% mark. So half that distance, so half our drivers are driving 25 miles an hour or faster. Because half the box, each one of these spaces is 25%. Just because it's a quartile. All right, now, what do you think about this one? Using that same data that you created a moment ago on this graph, went too far. On this chart, where is half the speed? What is half the things going slower than this speed? You're right, using that information, half the commercial liners are going slower than 490 miles per hour because that's our lower quartile, slower. That gives us the idea of that lower half. Oh, wrong way, my apologies. What does the length of the box tell us? Well, the length of the box right here tells us our IQR, where the length of the box plot itself tells us the range. Okay, so it tells us how, and that range will tell us how spread out the data is. Okay, and then our IQR, the larger the range, the more spread out it is. And then the IQR is going to tell me where the middle 50% is. So from 25% to 75%. All right, let's look down the next one. I've got to skip a page. Now, same box plot we're using. What does the box plot tell me about my data? So going back and using this information again, there's two ways you could talk about both the IQR and the range and figure that out. All right, so you'll see that the box itself tells me 50% of the airliners fly between 460 and 520 miles an hour. A range tells me that my data is very spread out, and that I had an outlier at 350. Okay, if I took out the outlier, my speed difference is only 90, which is a lot less than the range of the actual data. All right. What else I can talk about is I can actually find all my measures of variability by looking at a graph. So it says find the median. So the median, we're going to just put all of our numbers here based on this: Q1, Q3, IQR, range, and outlier. And again, we're not going to worry about finding MAD. We don't have the actual data, so we can't find MAD. So we're looking at this fitness club attendance. We're going to say daily attendance is probably 73. Since we can't have half a person, we're going to say it's 73. I'd also accept 72. My Q1, the lower 25% is 65 people. My upper 25% starts at 80 people. That means I have a swing in the middle 15, about 15 people in the middle 50% that are change. I have a range that's actually much, much longer than I originally marked. I have from, I'd say 56 all the way up to 110. So I have a range of 54, okay? And then finally we have an outlier out here at 110. That was a crazy busy day at this health club. I can find all that information. All right, go ahead and try the same thing. It says find the measures of center. It really just means the median here. Go ahead and find that, and then tell me a little bit more about your data using the size of the box plot, all that information. All right, so again, we're going to find the median. This time we're going to say the median is 56. We're going to say my Q1 is 54. My Q3, I'd say was 59. That gives me an IQR of 5, a range of 10. I don't have any outliers. So if I describe my data, something I'm going to say is it's relatively compact. The temperatures are pretty common, between 50 and 60 degrees. Okay, for the average low temperature. It's the second 25% of the data is very close, at only 2 degrees, where the third 25% is 3 degrees wide. I could say that the difference between the extreme and the upper extreme and lower extreme is 10. I could talk about the IQR, so where 50% of the days that we're looking at are between 59 and 54 degrees. So there's lots and lots of information. And when I say describe, I'm pretty much asking you for 3 pieces of data. All right, that gives you everything you need on the box plot.